For chapter 25, Polarity of Bond and Molecule. Now, there should be a term which is called electronegativity. What is electronegativity? We will say that the electronegativity of an atom represents the power of that atom to attract electrons in the bonding situation, but attract electrons towards where? Towards itself or to itself in a bonding situation. That is, so we are talking about the power of whether it is easy to attract electrons. Take an example for hydrogen and chlorine. They are two different atoms. The hydrogen, we assigned a value which is 2.20, while chlorine assigned the value to be 3.16. That means the ability of attracting the electron, or the power of attracting the electron towards itself, chlorine is higher. As a result, originally hydrogen and chlorine share their electrons so that they form covalent bond. They should share the electron placing in the middle. However, chlorine has a higher electronegativity, hence the electrons goes more likely to go to the chlorine atoms. As a result, the electron density for the chlorine atoms will be more, while hydrogen atom, the electron density will be lower. So electron density lower as electron is negatively charged. As a result, we say that hydrogen bears the delta positive, chlorine bears the delta negative. So a very famous scientist, Linus Pauling, he assigned the values for the different atoms. So covalent bonds between atoms of the same electronegativity results in nonpolar molecule. That is, they are nonpolar because the covalent bonds is not polar as well. As a result, they have even distribution of the shared electron. Hydrogen, they have same electron ability to attract the electron. Hence, they are nonpolar. Nonpolar bonds, nonpolar. But the covalent bonds between atoms of different electronegativities will make the bonds polar. Take an example for hydrogen and chlorine. Hydrogen has lower electronegativity value. As a result, it has lower power to attract the bonding electron. As a result, you can think about the classwork and then do it. Let's pause it and then you do it first. Now, we will talk about the answer. Mark the following bonds. Mark the atom with partial positive charge with delta positive. Delta positive means the electron density lower one. As a result, we take a look for the values that's given. Carbon, it is 2.55, while nitrogen, it is 3.04. Hence, you can see nitrogen has a higher power to attract the electrons towards itself. As a result, electron is more likely to stay near the nitrogen atom, makes the electron density for the nitrogen atoms more. So, it bears a little bit partial negative charge. The delta means just a partial, a little bit, while carbon, it is a partial positive charge. Another example, which is carbon and oxygen. You can see the values above. One is 2.55, oxygen is 3.44. Oxygen has a higher value. As a result, electron is most likely to stay near the oxygen because oxygen has a higher power to attract the bonding electron. As a result, it bears a delta negative charge because electrons bear negative, while carbon, it has already lost the negative electrons and then it stays near to the oxygen. As a result, carbon is delta positive. For fluorine and oxygen, we found that fluorine is 3.98, while oxygen is 3.44. So that means fluorine has a higher electronegativity. Hence, fluorine has a higher power to attract the bonding electron and makes the fluorine atom delta negative, while oxygen is electron is already being attracted by the fluorine. Fluorine having higher ability to take the electron, so oxygen becomes delta positive. The electron goes to the fluorine side. This is the part A.